Hello students, welcome to this video presentation on projection of planes. In this video, I Anthony Augustine would be discussing the problem of an isosceles triangular plate by auxiliary method. The problem statement says that the isosceles triangle plate of 40 mm base and 70 mm altitude appears as an equilateral triangle of side 40 in top view. We need to draw the projection of plate if its 40 mm long edge is on the HP and inclined at 50 degrees to the vertical plane. We need to find the inclinations of plate with HP and VP. We read the statement and try to find the keywords. So first we check for a edge or corner condition. Here it is mentioned edge is on HP. We use this for step 1, that is initial placement. Since the long edge is on HP, so we place the true shape, that is the isosceles triangular plate, the true shape 40 by 70 in the HP, that is in the top view below the XY line, and we'll obtain the front view. In step 2, we find the surface inclination. So since there is no angle mentioned for inclination with HP, so I use this statement equilateral triangle of side 14 top view. So the apparent shape is an equilateral triangle which is appearing in top view. So I will get the inclination in the front view, that is the inclination with HP. So the surface inclination is obtained by use of this statement. And finally I check for any other inclination. So here the edge on HP is inclined at 50 degrees to VP, and I use this and obtain the final position. So we are having 3 stages in which we will complete the problem. So I move on to the next step, that is the overview. So we'll solve the problem step by step in a quick manner. So I draw the XY line, draw the isosceles triangle 40 and 70 mm altitude, 40 mm base, which is perpendicular, base edge is perpendicular to the XY, and I project into front view, and I will obtain the front view in the form of a dark line. So I'll use this front view length in the second step. So I draw the top view, which is an equilateral triangle, which was second step, and then I project it into the front view and use this length over here to obtain the front view length position. So front view position is obtained by using this front view length over here. So I obtain the surface inclination, and in the third step I'll be using auxiliary plane. For that I'll be using a line which is inclined at 50 degrees to this edge, this vertical. So if I extend, the angle would be 50 degrees angle. So I project the corners through perpendicular projectors onto this auxiliary plane, and then take distances from the XY and mark it on it. So projectors from the top view, distances I have to measure from the front view. So point A and this 2 points are on the HP XY line. So on this auxiliary plane also they would be on the XY line. This corner point is above, so hence its projector, this point would be above, the distance would be from X to this point in the front view. So I'll get the final view such. Remember, the inclination was taken with respect to this vertical edge which was on the HP. So now we'll move on to the actual problem solving. So the problem solving starts with writing the data, drawing the XY line and the perpendicular on which I start marking the base of 40 mm. Find its center, and using a protractor I'll erect a vertical to the base edge. I take altitude of 70 mm and complete the triangle the required isosceles triangle. And since this is the top view, I'll provide the name A, B, C. I'll project the corners into the front view and I'll obtain the front view, which should be relatively dark. I name the points A dash, B dash and C dash. This is step 1, that is the initial position. So I'll use this initial position in the next step. So the direction of flow is top view to front view, and now I'll be using the front view in the next step. So I'll use projectors to transfer distances into the second step, where it is given that the top view is an equilateral triangle. So I draw the base AB, and since this is the second step, I name this A1, B1. I take the side 40 and complete the equilateral triangle using arcs. So I find point C using arcs of 40 from A and B respectively. I find the triangle and name this new point C1. Now I project the top view into the front view like this, and remember AB is on the HP while C is above. So I take distances from step 1, and since AB is on ground, so I mark it on XY. So A1 dash, B1 dash is the point. I take distance A to C, AB to C, mark it on the projector of C1 to obtain C1 dash. So this gives me the front view of the inclined plane and the angle, that is the surface inclination. So to the base A1, B1, I need to draw an angle of 50 degrees. So I am drawing an angle of 50 degrees, and I'll draw a faint line, and remember the auxiliary plane should be at angle of 50 degrees like this. So I take it further away, and then I'll find the auxiliary front view on this new auxiliary vertical plane. So I need to draw perpendicular projectors onto the auxiliary plane. So I need to construct a vertical. So before that, the angle I am showing 50 degree to the base edge A1, B1. Now I construct a perpendicular to the auxiliary plane x1, y1, and through points A I draw projectors. So remember, I am taking distances from xy. So projectors from top view and distances from front view. So A and B in the previous step were lying on the xy. So similarly, A and B in the new vertical auxiliary vertical plane would be also on the ground. C projector I have projected. Okay. So remember, projectors from top view and distance from front view. So A lies on the x1, y1 line. B would be lying also on the x1, y1 line. However, C is above, which I measure from the front view and transfer it onto the projector. Distance I am marking from x1, y1, and I find C1, and then I complete the triangle by joining the newly found points. So this is auxiliary front view. Thank you for your patient listening.